In this room, I have something which is incredibly common in the universe, but very rare on Earth. It's so rare, in fact, that it was first discovered on the Sun before it was discovered on Earth. I'm talking, of course, about helium, the second most abundant atom in the universe, named after the Greek god of the sun, Helios, due to its discovery. And if I pull on the string, we find why I have helium here. So I've got a bunch of helium inside of this birthday balloon. And aside from making cool balloons, helium has a lot of other interesting uses, especially in science. It's used to cool experiments down to extremely cold temperatures, very close to absolute zero, and it's also used in some pretty cool Bose-Einstein condensate experiments. Although helium is really cool and very useful in balloons and science, it's not that present on Earth. And the main reason for that will be demonstrated by this balloon as soon as I let it go. The balloon rises. This is because helium has an average kinetic energy which is greater than the energy required for the particles to escape Earth's atmosphere. So that of course means that helium balloons rise in a very cool way, but it also means as soon as helium starts rising, it'll drift off up into space. So you've all probably seen at fairs and parties helium balloons drifting off into the sky, lost forever. As the balloon will float up into the atmosphere, the pressure will drop and the balloon will expand. Eventually that balloon will pop, releasing its helium off into the upper atmosphere to eventually escape into space. So if helium wants to escape from the surface of the Earth, where do we actually get it from? We don't have any massive farms on the sun scooping up as much helium as we can, so where does all of this helium for party balloons and science experiments come from? To answer this question, we're going to need to take a trip deep down through the surface of the Earth, right down to its core. And right at the core we'll discover something rather interesting. The core of the Earth is extremely hot. It drives all of the convection patterns which produce the Earth's magnetic field and all of the plate tectonic motions. But where the Earth gets its energy to keep it so hot comes from something very small inside of the Earth. We're talking about radioactive atoms, things like uranium. So we're very familiar with nuclear power plants on the surface of the Earth, where we have things like uranium which undergo nuclear fission and break down into smaller particles. Now the Earth is powered the exact same way we power these nuclear power plants. Right at the center you've got radioactive atoms which are breaking down, firing off smaller particles. And one of the reactions that happens in the center of the Earth is one which produces something called an alpha particle. Now if you have a big heavy atom like uranium or plutonium sitting around, it wants to make itself smaller and break down. So one of the ways it can do this is by firing off an alpha particle, which contains 2 protons and 2 neutrons. Now if you're familiar with the atomic structure of atoms, you'll notice that 2 protons and 2 neutrons is what a helium atom is made out of. So this is actually what's happening. These radioactive decays which produce alpha particles are actually producing helium nuclei. These helium nuclei fire off into the surrounding material and steal electrons from the other atoms around it and become a fully fledged helium atom. Now over the course of thousands of years, these helium atoms will make their way up to the surface of the Earth and getting caught in massive gas pockets beneath the Earth's surface. So where we find natural gas below the Earth's surface is also generally where we tend to find pockets of helium. And we get helium out of the Earth's surface through the same way we get that natural gas out. Now we have helium mines dotted throughout the world extracting all of the precious helium from the crust of the Earth. As you might have guessed from this process, helium's not an unlimited natural resource. It's actually pretty rare. And its rarity has prompted many physicists and scientists to be concerned about the future of science experiments, because the vast quantities of helium which is required in science to cool down experiments increases over time, but the supply of helium doesn't necessarily do so. And of course we have the other problem. Helium is used in helium balloons. And we know that the fate of pretty much all of these helium balloons is to float off into the atmosphere. So what we're left with is to try and work out how to best use helium going forward into the future. Because at the moment helium is crucial to very important technologies and experiments. But it would still be cool, of course, to have helium balloons in the future. I'm not saying we should completely get rid of helium balloons. But next time, if you're at a party that has helium balloons around the place, take a moment to think about the processes that led to the helium being inside of the balloons. Remembering that the helium has come from the very core of the Earth, from nuclear reactions which power the convective motions, and the fate of these helium balloons. All of the helium inside this balloon will eventually find its way up into space, just like the helium in every other balloon. All because of their remarkable property to float away. But there's also something else you might find interesting about this helium balloon, is that it's deflating, it's losing air. All balloons deflate over time, but there is a property of helium which is kind of related to it, and it's pretty cool. So if you want to learn some more about another property of helium called superfluidity, there'll be a link to the next video over top of this video here. And until next time, thanks for watching, and I hope you learned something about helium.